Hi everyone. In this video, you're going to learn about recursive and explicit formulas. So to begin with, let's just go over some basic definitions. So to begin, let's go over what is a recursive formula. So a recursive formula is a formula to find the next term in a sequence that is dependent on the term before it. So we'll get to understanding what each of this means later on in the video, but just as a brief gist, a recursive formula would be something like to find the next term, add 3 to the term before it. So now let's move on to defining what an explicit formula is. An explicit formula is a formula to find the next term in a sequence that is dependent on the term number, or term position is actually a better term position. Okay, so the first thing we're going to do is, first of all, just define what term position is. So I've actually defined this in my arithmetic sequence video, but if you haven't watched it, please do. It really helps to understand this. But just to give you a brief gist, it's the position it has in a certain sequence. So like, say there is a sequence with the numbers. Let's see. Say we have set A, and say you have 2, 4, 6, and 8, right? So basically, 2's term position would be A1 or just 1. 4's term position would be A2 or 2, and so on and so forth. Okay, so now let's get into when each type of formula is used, right? So recursive formulas are used when you have a small amount of terms, right? So for recursive, I'm going to denote it as R. It's when you have a small amount of terms. Apologize for any background noise. Okay, so when you have a small amount of terms. So what do I mean by small amount? I mean, maybe something from 1 to 6 terms. And if you're particularly good at math, maybe somewhere around 12 terms at max. Okay, so basically the basic denotation for a recursive formula would be something like an, or the term you want to find, is equal to an minus 1, which is the way for denoting the term before it, plus, minus, or multiply / divide by a variable, by x maybe, or with any extra operations you want to do to the previous term, right? So the reason why this isn't really efficient is because, say you had to calculate the 101st term, a sequence of set A, right? Imagine having to find 100 entire terms. So that's basically like, I don't know. I don't even know what the 100th term would be. Yeah. And then adding 2 to it, that would be quite impossible feat, or adding / multiplying x to it. That is quite the impossible feat for complicated sequences, right? So recursive, in short, are when you have a small amount of terms and the formula is dependent on the term before it. So it really should have a term like this, right? So what about explicit formulas, right? Explicit formulas you use when you have a large amount of terms, or even just a lot, just like explicit can be used anywhere, right? It's one of the most efficient ways to find the next term in a sequence. So really there are no restrictions on when to use explicit. And actually neither are there on recursive, but it's just a suggestion that you don't use it when you have a large amount of terms. So an explicit formula would look something like, in order to find a of n, you take 2 plus n minus 2 times 2, right? Something like that, because right now you're depending on the term position, which is n, right? I'm gonna highlight that in a different color just so that it's easier for you guys to see. N and n, you depend on the term position. Okay, so now let's get into writing some recursive formulas, right? Recursive and explicit formulas. So first, let's look at a set, right? I'm gonna convert into a different color. Actually gonna draw a line so that you guys can see. Okay, so say we have -5, -0, oh, not -0. Okay, say we actually have -1, then 3, then 7, then 11, all the way, 7, 11, nice. Okay, anyways, let's try writing a recursive formula. So we know that a recursive formula is dependent on the term before it. So a recursive formula would mean, it would be something like, okay, I know that I have to add 4 to get to the next term. So let's just write that down. I have to add 4, add 4, add 4. So I'm seeing a common pattern that in order to get to my next term, I have to add 4 to the previous term. So that's exactly what we're going to write, just in a fancy way, right? So an, or the term you want to find, is equal to an minus 1, or the term before it, plus 4, right? But there's one problem here. If n was to be 0, the term before it would have to be -1. Same with even 1. If n is equal to 1, then the term before it would be term 0, and there really is no term 0 in this. Term numbers always start from n equals 1. So here, we need to put a domain restriction. So for recursive and explicit formula, for recursive actually, I take that back, you have n is greater than or equal to 2 as your domain restriction, because you know that in order to start from n is equal to 1, you can only go from 2 and above, not anything below 2. So that's your recursive formula. So now let's try writing an explicit formula for this. So if you've seen my video on arithmetic sequences, you know exactly how to find this in an easy way. So we know that since this is an arithmetic sequence, the common difference is equal to 4. So since a1 is equal to -5, remember always write out your first term. And d is equal to +4. We're going to write out our formula. A1, or -5 plus n minus 1 times 4. And now we're just going to expand all of this, right? So 5 plus 4n minus 4, which is equal to minus 9 plus 4n, which is now our explicit formula, right? So again, now we need to put a restriction on the domain because we can't find the negative first term or the 0th term. So here our domain restriction is also going to be n is greater than or equal to 2. So just remember that there is a new concept of domain restrictions introduced here, just so that you don't forget that you can't find the negative first term, negative second term, so on and so forth, right? So just always remember that your formulas for either recursive or explicit will not be considered valid unless you have a domain restriction, which is really important. Okay, so that is an example of creating a recursive and explicit formula. So just remember that whenever you have a formula, a recursive formula is dependent on the term before it, and an explicit formula is dependent on the term position. So if you have that memorized and if you understand the domain restriction rules, you'll be all set for any question depending on recursive and explicit formula. So I just also wanted to let you guys know that I've created a note sheet and worksheet for this. I'll be posting answers shortly after I post this video. So please be sure to look out for that. And yeah, thank you so much for watching this video. I hope I answered your questions. If you have any more questions, please do put them down in the comments and I'll do my best to answer them. Thank you so much. Bye.